Hello, this is Dumediat. It's been a little while since I've appeared on BremSter's channel, but hope you're all doing well. Today I'm bringing you a video of a puzzle called 159 Zig Zag by Weidman. I checked on Logic Masters Germany. It looked like this puzzle was published about 2.5 years ago, so been around for quite some time, but I'm excited to give this one a try. Thanks to BremSter for inviting me back on the channel to solve a puzzle for you all. Let's get right into it. So this puzzle uses normal Sudoku rules, so every row, every column, and every 3x3 box contains the digits 1 to 9 once each, with no repeats. We have German whispers lines, so digits along the line, adjacent digits along the line must have a difference of at least 5. So if I were to place a 7 in this cell, for example, the cells next to it would need to be at least 5 apart, so that would be either 1 or 2 in either direction. That's how those lines work. And we also have box indexing. This is similar to 159 if you've solved that type of puzzle before, but a little bit different in how the indexing works. So I want to mark this central box using box positions. So the way it works is this blue box in position 1, I'll just mark these now as the positions. This goes 1 to 9, left to right, top to bottom in reading order. So this blue box in position 1 of each of the 3x3 boxes, the blue cell will tell you, whatever digit you put in it, will tell you which position in that 3x3 box the 1 goes. For the central cell, it'll tell you which position the 5 goes, and in this bottom right corner, it will tell you where the 9 goes in that box using these positions. And so let's pick this cell that's sort of out of the way here. If I were to put a 3 in position 1 of this box, so let's just highlight, well, I won't highlight it here just because the blue will override it, but this is saying that the 1 in this 3x3 box is in position 3, so the top right corner, which corresponds to position 3 throughout the grid, are in these yellow cells. So it's saying that the 1 goes in position 3 in this 3x3 box. Similarly, if I were to put a 2 in the central cell, it's telling me that the 5 is in position 2 of this box. And if I were to put a 7 here, the 9, because this is in the bottom right corner in position 9, tells me it goes in position 1, 2, 3, 4, 5, 6, 7 in this box. Now we can also have self-indexing cells. So we could put a 1 here, for example, and it's just telling us the 1 is in position 1. And that's already where it is, so this would be self-indexing. And we could also have a situation where we have a 9 in this, which is telling us that the 5 is in position 1, 2, 3, 4, 5, 6, 7, 8, 9. And the 9 is in position 5, 1, 2, 3, 4, 5. So these sort of cross-reference one another. That's allowed in this rule set. Okay, those are the rules. I'll do my best to explain the indexing as I go as well. But I want to go ahead and restart my timer and give this one a try. So we're looking at this in the example, but these German whisper lines combined with this indexing are interesting to me for a couple of reasons. So first, a rule of German whisper lines, or a result of the logic of German whisper lines, is we can never put a 5 on the line. Because if we do, we need to have a digit next to it that's at least 5 apart, which would either give us a 10 or a 0. And in this puzzle, those digits are not allowed, those numbers. So we can't put a 5 anywhere on this line, which means that in this box, the 5 must be off the line. But we also know with this puzzle that whatever digit we place in here will tell us which position the 5 goes in. And the way it stands now, the 5 can only be in positions 3, 4, 6, and 7. The same is going to be true over here because this box is just a clone of this box. For this from that perspective, so this is also going to be 3, 4, 6, and 7. But something else with German whisper lines are keeping in mind 4s and 6s. 4 and 6 are each digits that can only be next to one other digit on the line. So if I were to put a 4, let's say on this German whisper line, I need a digit that's 5 away. I can't go down because I'd go to -1, so I'd have to go up to 9. So 9 is the only digit that can go next to a 4. And in a similar way, the 6, I can't go up, I'd go up to 11, so I need to go down to 1. So 6 can only ever go next to 1. So if I try to put a 4 or a 6 in this central cell of this box, if I put a 4, I need 2 9s here, or if I need a 6, I would need 2 1s here. So these can't be 4 or 6. So we end up with a 3 7 pair. We also know that the 5s are going to be in positions 3 and 7 of these two boxes. So I can delete these 5s. And the question to ask now is, where does 5 go in row 5? It can't go in these cells because the 5 is in one of those two positions, and same here. So our 5 in row 5 has to be in one of those 3 cells. And again, we're indexing, this cell is indexing the position of the 5, which can only be in positions 4, 5, and 6. So that's either 4, 5, or 6. Very nice start. I'm going to use high-low coloring for these lines. Oftentimes it makes it easier to visualize what's going on with German whisper lines when you can color them high-low. And we have these blue color, but I'm going to use red and yellow just to signify. One of these is a low digit, and by low I mean 1 through 4, anything below 5, and a high digit will be 6 through 9. And we know one of these will be a 7, one of these will be a 3. We don't know which, but we do know that the colors along the lines will alternate as we move down the line. So these two cells will also be yellow, and then these two will be red. Whichever one is high or low, we don't know yet. And the opposite is true over here. Okay, so if I have a 7 here, when you see 3 and 7 in the middle of the line, you should take note of what can go next to it. If it's a 7, we will have a 1-2 pair around it, because 7, the low digit, we can't have a 3 because that's only 4 away. So we need to be at least 5 away with a 1 and a 2. And then if that's the case here, these would be 6, 8, and 9. We don't know which yet. Although we would have a 1 in one of these two spots. So this cell couldn't be a 6, for example, because I would put a 1 here. And actually, it couldn't be, this cell couldn't be a 1 because this would need to be a 2 in that case. So it actually would need to be forced in this direction, with the 1 being in position 8. So we'd have a 7 and 8, and then 1 could be next, 1 could be next to 6 or a 9. So that's if yellow is high. This would have to be the exact layout of the box. Let's actually just keep that here. And because we have a clone over here, let's just use this for the other case. If this is a 3 can only go next to 8 or 9 along a German whisper line. And then these would be low from 1, 2, and 4. But again, this cell indexing the position of the 9 would have to go in positions 2 or 8. But you can't put an 8 here because this would be basically 2 high digits next to each other along this line. So this would have to be a 2, with this being a 9 and this being an 8. And then this cell could be 1 or 4, which would put a 1 in one of these two. Okay, so those are the two options we have. And so what I'll do is I'll just copy these over. Because effectively what we're going to get is a couple of pairs in these rows that might help us further whittle down what can go in the central box here. One other thing I noticed with these is if yellow is low, then the 2 is here. But if red is low, then the 2 is here. So in either case, the 2 is going to be in one of these two spots, and the same thing is going to be true here. So we can do a similar trick we did with 5s and ask where 2 can go in row 5. It can't be in any of these 6 cells because of where it goes in the box. It can't be in the central cell, though that has to be a 2 in one of these two positions in box 5. And we're going to get something similar with 8, yes. So using kind of inverse logic, if yellow is high, then this is our 8. If red is high, then this is our 8. So 8 is going to be in one of those two positions. Remember, these two are basically clones from this perspective. So again, 8 in row 5 can't be in these cells. So we end up, and it can't be in the central cell, so we end up with 2 and 8. Now, if you've not seen this trick before with corner pencil marks, or what's called Snyder notation, we have 2 locked into one of these 2 spots in box 5. But we also have 8 locked into those exact same spots in box 5. So if we put a 2 here, then this is going to be an 8. Or vice versa, if that's an 8, that's going to be a 2 because there's nowhere else in this box for those digits to go. So if we were to try to put a 5 in this cell, then this cell has to be both 2 and 8, and that doesn't work. So what you can do when this happens is convert your corner marks to pencil marks, which tells us that the only digits that can go in these 2 cells are 2 and 8. And these took the positions of where the 5 could go in the box. So the 5 actually has to go in the central cell. It's kind of a cool way of getting the first digit there. I didn't necessarily expect to get a 5, although it is self-indexing, so we don't get any other digits from that, but at least that cell is done. Okay, what else can we get from this? So the rest of the cells in row 5, we've got a 3-7 pair and a 2-8 pair. So these are from 1, 4, 6, 9. Okay. That's interesting, I think. I'm looking at 4s and 6s. I'm just asking myself if, oh no, maybe the thing is to look at is 1 and 9. I think that's clear because, okay. The question I'm asking is, can both of these be 1, 9? Can we do this where we have 1, 9 in one box and 4, 6 in the other box? And the answer is no. And the reason is because yellow here. If yellow is low, this is a 1. And this is a 2. If yellow is high, this is a 9. So no matter what, if yellow is high or low, there's going to be a 1 or a 9 in yellow. If we did this, we would have then a 2 here and an 8 here. And now yellow is both high and low. And so whatever we put in this cell, if we put a 3 here, it breaks the 2. If we put a 7 here, it breaks the 8. So that doesn't work. We have, and if we do 4, 6 here, the same problem happens. We get a 1, 9 over here, and then red breaks for the exact same reason. So we have 1 of 1 and 9 and 1 of 4 or 6 in these 2 cells. And that's interesting because we have what we can call the yellow 1, 9. It's either in this cell or this cell, depending on which one, whether yellow is high or low. So we can kind of think of this as being like the red 1, 9 that would be in this cell is in one of these 2 cells. So none of the other cells in this box outside of these 4 cells can contain 1 or 9. If we did, and let's say we try to make this a 1, well, now we know we don't have a 1 here. We do have a 9 because we need 1 of 1 or 9. But because 9 can't be here, this would become a 2. And we get 2 low digits right next to each other on the line. So our 1 and 9s are taken up in these 4 cells in this box, which is very cool. So I'll just mark these as 1, and I'll mark these as 9. And I'll come back to that in a minute, but we can take 1 out of this cell, and we can take 9 out of this cell. And the exact same thing is true over here. We can take 1 out of here, 9 out of here, pencil mark our 1s, and oops, I did that wrong. Pencil mark our 9s, and then pencil mark our 1s down here. That does a few things. We'll do the Sudoku thing first, and then we'll do the indexing thing. So our 1s in boxes 4 and 6 are in rows 5 and 6 only. So the question to ask is, where can 1 go in row 4? Can't go in these cells for the reasons we said before. Can't go in these cells. So our 1 is up here, which tells us, remember this cell is indexing R1, so it's in position 1, 2, or 3. So this is 1, 2, or 3. Except it's not 2 because we have a 2, 9 pair in row 4. So this is not a 2, and that can't be a 1. And again, with 9s, we have in boxes 4 and 6, our 9s are in those spots in rows 4 and 5. So in row 6, our 9 has to be down here. This is position 7, 8, and 9. So this cell, which is indexing the 9, has to be 7, 8, or 9. But we've got a 1, 8 pair here, as expected. So we have no 9 in this cell because we can't put an 8 in this cell. I like how we make a deduction. We can kind of use it a couple different ways in this puzzle. Very nice. So I did mention 9s in this box. So remember that this cell is indexing our 9. So this is position 2, 4, and 6. But we know that this is only 2 or 6. It can't be a 4. So this can't be a 9 over here. If we did, this would be a 4, and then this wouldn't work in this box. And so the same logic is going to apply. Since this can't be a 4, this can't be a 9. Okay, and then checking our 1s, 4 and 8. So this is positions 4 and 8. So this cell can't be a 1. And again, over here, the same thing is going to be true. Okay, so if this is 1, this is a 4, 6. If this is 9, that's a 4, 6. That makes sense. All right, and so we have, interesting because none of these cells can be 3 or 7 now. So these cells are actually from 3, 7, the other 3, 7, the yellow one, or a 5. And same thing is true over here. These are 3 from 3, 5, 7. All right, so let's try to think about these cells, because they can't be 1, they can't be 2. We could have 3. It can't be 4 because we have a 4, 8 pair in the row. It can't be 5. It could be 6 or 7. It can't be 8. And it can't be 9 because of the 2, 9 pair. So this is either 3, 6, or 7. And this cell can't be 2 because of this. Can be 3. Can be 4, not 5. It's not 6 because of the 2, 6 pair. Could be 7. Can't be 8. And it can't be 9 because that can't be 8. Okay. Don't know how much that actually does at the moment, but it is restricted, so I guess it's worth noting. Maybe it'll help us later. And then this is probably not as restricted because it can also be a 1. So we're missing 2, 4, 8, and 9. And it can't be 5. So this is 1, 3, 6, 7. And this is missing 1, 2, 6, 8, 5. So this is 3, 4, 7, 9. Okay. So not very restricted, but at least something. All right. I don't think we're getting anything else with this, just because I don't think anything with the indexing breaks. Like if this is 8, this is 1, that's 2, and that works from the line. We already did all that logic. And if this is 4, that's 1, that's 8, that's 9, and that works as well. 4, 9 is okay next to each other. And we have our 1, 9 with our other 4, 6, and then same thing here. I don't think we're going to get much else. So let me get rid of these colors, because it's also not telling us these longer lines. I wonder if that's is another place to look. So let me delete the colors for now. Now that they're down to pairs, it's going to force each other once we get one of these digits anyway. So let's look at this line. So alternating, let's make those yellow. make those red. So these are both indexing a 5 in their boxes. So, oh, that's interesting. And they're also the same high-lowity on the line. They're either both high or they're both low. High being 1 through 4, 6 through 9, and low being 1 through 4. But we also have to keep in mind the position numbers. So let's just say, for example, these are both low. It's not going to matter. And if this is low, this can't be a 4 because we would need 2 9s here, like we talked about earlier. So this would be 1, 2, 3. And this could be a 4 with a 9 here because it's just at the end of the line. So this could be 1, 2, 3, or 4. But this would be saying that the 5 in this box is in positions 1, 2, or 3. So somewhere up here. It couldn't be here because there's already a 5 in the column. But this would be saying that the 5 is in one of these spots also, but it couldn't be up here. So it would have to go here because of entropy, really. Entropy being sort of 1, 2, 3, 4, 5, 6, 7, 8, 9. We can't have in these rows, oh, this is kind of like an entropic line type thing where, oh, there's going to be a few things that we're going to do with this. This is cool. Okay, so if we put 2 digits of the same entropic strata, so 1, 2, 3, 4, 5, 6, 7, 8, 9, let's say this couldn't be a 4, we would also be putting a 5 up here. So we'd be indexing a 5, 2 5s in the same row of the Sudoku. And so if this is 1, 2, 3, or 1 or 3, these 2 cells can't be from 1, 2, and 3 anymore because we can't put 5s up here. So this would have to be a 4 because it's in the same high-lowity on the German whisper line. But a 4 would place a 5 here on the whisper line, which doesn't work. So I sort of lucked into that example here, but the point stands that actually yellow in this line is high. So from 6, 7, 8, 9, this can be a 6 with the 1 here. This could be a 6 with both 1s, but this can't be a 6 for a couple of reasons. And so now the 5 in this box is in one of these 3 spots. Can't be 5 here for a couple of reasons, the line and the existing 5, so that can't be an 8. And so now this cell can't be 7, 8, 9 because we already have our high entropy in these 3 digits. Putting a 7, 8, 9 here would put a second 5 in row 3. So this has to be a 6 with a 5 here. And then this has to be a 1. That's very cool. I really like that. I hadn't appreciated it when I first looked at it, but there's going to be something else we can use here in just a second. Let me clean up these this whisper line. So we know red is low in this line. So 4 can't be here because it'd be 2 9s. 4 can't be here. Actually, 4 can't be here. And 3 can't be here because if this is 3, this needs to be 8 or 9, and it can't be. So this is 1 or 2. And this has to be high, and it's going to be 6 or 7, but it can't be 1, importantly. So our 1 in this box now can only go here. So that's our self-indexing 1. Again, we don't get any sort of more digits being thrown by this, but that's okay. Okay, so let me delete the coloring here. Something else cool, before I try to copy that logic down here, is in columns, we're going to get a modular restriction. And by modular, if you think of your keypad, entropy is your rows of your keypad. So 7, 8, 9, 4, 5, 6, 1, 2, 3. Modularity is the columns of your keypad. So 1, 4, 7, 2, 5, 8, 3, 6, 9. And what that means is when you divide each class of digits by 3, you get a remainder. So the 3, 6, 9 class has a remainder 0. The 2, 5, 8 class has a remainder of 1. And the 1, 4, 7 class has a remainder of 2. When you divide, or sorry, I think I had that backwards. Yeah, it's 2, 5, 8 has a remainder of 2, and a 1, 4, 7 has a remainder of 1 when you divide by 3. So in the column, this 6 is putting a 5 in column 9. So if we tried to put a 3 in this cell, we're also going to be putting a 5 here in column 9, and it can't be. And so we're going to have one of each modular class in the columns and one of each entropic class in the rows. It's a very neat implication of this rule set. Any grid that's going to have this rule with these blue cells in it will have that property. So before we move on too far, we know in this row I said we need a low, middle, and a high entropic class. So we have our middle, we have our high. This has to be from 1, 2, 3. Placing a 5 up here. That can't be 5, so that can't be 1. And here we have, this can't be a 3 because this can no longer be a 5. So this is a 7. Oops, got my colors on. That's a 7. That's a 5, and that's a 3. That's probably going to do some Sudoku stuff. Yep, that's going to do a lot, actually. We did all this work before. We can actually undo all this now. So we know this is high 2, 8. 8 is going to put 1 here, which works for our line, and this is a 6, which places a 9 here in position 6. And this is then a 4 by Sudoku. So let's just double check our indexing. 8, position 8 is a 1, position 7 is a 5, and position 6 is a 9. So that's all good. The 7 makes this a 3. It has to be next to a high digit, and that makes this a 4. So 4 is here in the box, position 1, or the 1 is in position 4. 3 goes next to 8. 8 goes next to 2, and the 2 is indexing the 9, which is correct. Get rid of our 3s here. 4, 9, so this is a 6. 5 is in position 3, so this is our 5, and this is our 7. 3 looks over. We've got 6, 7 pair here, a 2, 8 pair here. This 7 makes this a 9, so we get another self-indexing cell in box 5. 7 is taken out of here by Sudoku for a couple reasons. Okay. Take a breath. That's really, really, really cool. I hadn't appreciated that, but I really like that property of this rule set. Okay, so now we've got this whisper line, our high-low polarity, I guess we can call it, is resolved. So we know this is high, and it has to be an 8 or a 9 because this is a 3 or a 4. That's 1, 2, 3. Can't be a 4 because this can't be 2 9s here. This is 7, 8, 9. Can't be a 6 because we put 2 1s on the line. 1, 3, 4 by Sudoku can't be a 2, but it could be a 4 with 2 9s. That would be okay, I think. This is 7, 8, 9. Can't be a 6, and then this is 1, 2, or 4. Can't be a 3 by Sudoku. Okay. So before I resolve this, I want to look, oh, I can actually do a little bit more. This 3 looks like making this a 2, which makes this a 5 in position 2. So our 5, well, we can do, I want to use my modular trick here instead of Sudoku. So we've got one from our 258 class, one from our 369 class. So this needs to be from our 147 class because we need, another way to think about that is we need a 5 in column 1. So the 5 has to go over here, but because this can't be a 7, this can't be a 5. So our 5 is here somewhere. What else can we do? Well, we can start looking at some of this indexing. So the 1 is taken care of, the 6 is taken care of. Here we've got our 7, 9. Just making sure I'm not missing any Sudoku while I'm doing this. That's 2 sees this. Okay, so let's take a look at the 9 in here is in one of these 3 spots, position 7, 8, 9, but it's not here. So this can't be an 8. That's position 8. This can't be a 7. And the reason for that is if this was a 7, this would be a 1, 2 pair because 7 can only go next to 1 and 2. But these 2 cells can't be 2 by Sudoku. So this actually has to be the 9 and be self-indexing, which takes the pressure off the low digits, but that's okay. The 5 in this box is in position 1, 2, and 3, but it's not in position 2, and so this can't be a 2. Okay, if this is a 4, that's a 5. Did I miss anything else with Sudoku at this point? I don't think so. So maybe we can use our modularity. Oh, yes, I did forget one step with our entropy with these 3 cells. We have our low digit here, so we have a 5 in one of these 2 cells, which means that can't be 5. Or this can't be a low digit, so this is going to be a middle digit. And that puts a 5 here. A couple ways of looking at that, but I like the property, so I'm going to use it. Okay, so we get a 1-3 pair here. So we have a middle, a low. We need a high digit here. Can't be 7, so this is 8 or 9. And apologies, I keep flicking between low and high. When I talk about entropy, I know it's only 7, 8, 9, but the whisper line, I include 6. I'm trying to be clear while I'm doing this too. So 8 and 9, so our 5 is in one of these 2 cells, but it can't be here because of the whisper line, very cleverly placed. So this has to be the 8 with a 5 here, which means that can't be an 8. What do we need in this column still? We need 3, 4, and 9. I think those are all okay. Our 1, we can use our modularity here. We have a 1, 4, 7, a 2, 5, 8, so we need a 3, 6, 9. Or in other words, we need a 1 in column 9. So it's in one of these 3 spots. I don't see that being eliminated by Sudoku, but I do see this 8 lookup. That gives us a 7, 9 pair. Notice the symmetry up here. So let's look at these remaining cells. Well, first let's look at this. We have a 3, 6, 9, a 2, 5, 8, so we need a 1, 4, 7 here, or we need a 9 in column 1. Same logic we did over here. Okay, let's look at these cells because we have a 7, 9 pair. So these are from 1, 3, 4, 8. Oh yeah, okay, so this can't be a 9. And so this can't be a 4. This sees a 1 and a 4. So this is either 3 or 8. Okay, so if this is a 3, this is 8 or 9. If this is an 8, it can't be 1 or 2 by Sudoku, so it would be a 3. So we do need a 3 that is the only low digit that can go on this line, so the 3 goes here. And then by Sudoku in box 7, the 3 goes in one of these 2 spots, so this is not a 3. I suspect we can do something similar down here, but so let's look at these cells. This can't be 1, 3, so we still need 2, 6, 7, 9. That can't be 9. And this can't be 6 or 9, so that's 2 or 7. If this is a 7, this is a 1 or a 2. And if this is a 2, it can't be 8 or 9, so this would be a 7. So we do need a 7 here, 7 there, so one of these 2 is a 7. Okay, so our 9 in this box is in one of these 3 positions. So 9 is in one of those, so this is not a 9. Did we do that over here with the 1s? It's in position 3. Yep, so the 1s are here. This is not a 1. Okay. So we've got in row 2, our 1 is in one of these 2 spots. And so this, oh, there's a few things we can do here just by not missing Sudoku. But the 1 is in one of these 2 spots, so this has to be a 4 or a 6. But also, this one looks over, taking 1 out of this cell, so this can't be 3. So this is 8 or 9. This has to be a 3. That makes this a 1. Makes one out of here, and this one makes this a 6 because it's position 6. Getting sloppy with my Sudoku, so let me just do some scanning, make sure I'm not missing something. Don't see that we are. Oh, this 9 is the same thing we did up there. So this 9 looks over, so the 9 has to be in one of these two cells. So this is either a 1 or a 2, but not a 7. So our 7 has to go here. Take 7 out of those cells. And then that makes this a 9, which this is position 4, so that places a 4 here by Sudoku. Nice, we're making good progress now. Okay, so let's look at this cell. So we've got our 9s in, we'll use Sudoku here. Our 9s are in one of those two spots. So this is a 2 or a 5, which makes sense with our modularity trick we were using. I don't see 2 and 5 looking at that cell, so we'll move on. This is showing the position of the 1, which I think can still be in a few spots. Oh, this 1 looks at this cell, makes this a 2. 2 by Sudoku can only go here and then down here. So this 2 looks at this, makes this a 1, which then indexes a 9 here. That's not 9. This 9 looks up, makes this a 7. That makes this a 9, which makes this a 5. So we've got sort of cross-indexing cells here. This 5 is in here. And our 5s, this can't be a 5, so our 5 is right here in position 1, so more cross-referencing. And this 1 looks over, making that a 3. Probably a lot of Sudoku that I could be doing right now, but let's just look at these pairs. So this 1 is going from this cell. 1, 2, 3, 4, 5, 6, 7, 8. So 4, 8 pair. Being helped out by Sudoku? I don't think so yet. Oh, this 8 here makes this a 4, and this an 8. This 8 indexes the 9. So we got a 9 there. And then this needs to be a 3 or 4, but it's not a 4. So that's a 3 and that's 4. That's a 3. And then we've got a 2, 6 pair here left in box 9. Okay, so all our indexing over here is done. Let's look at what we want to look at next. Just looking for pairs in normal Sudoku, but I don't think I see. Oh, this 9 looks at make this an 8, which means this is a 3 and a 4, because 4 can't go next to 8 on the line. Okay, this column still needs 3, 6, and 7. This can't be a 6. See, these are 2 from 2, 3, 6, 7. This can't be 3 or 6. So that's 2, 7. This can't be a 3. Eight in row 9. Can't go in those cells, and this one's used by Sudoku. So that's an 8. That's a 9. That puts a 1 here. And the only indexing we have left to do is here. So we need a low digit, and that's a 2. So it can't be 1 or 3. And the reason it's low is this is middle, this is high. Or, we can't put a 8 here because there's already an 8 in the box. So that's a 2 with a 1. That's not a 2. We have a 2, 6, 7 triple, so that's a 3. That's a 7. That's a 6. That's a 7. That's a 6. That's a 2. 8, 2, 7. This is 4 or 8 for the column, but it's not 8. 4, 8, 4. 6. And then we need a 7 and an 8 here. That's not 8. 7, 8. This box needs a 3. This 2 makes this a 6 and a 2, and then we have 6, 7 left. The 6 makes that a 7 and then a 6. And that is the solution to 159 Zig Zag by Weidman. That was very cool. I really enjoyed the indexing logic there. And the German whisper lines, it's symmetric, but it's not totally symmetric because we've got, these aren't mirrored. But I did like that once we made some deductions, we were sort of rewarded by being able to put it in 2 spots. And it was really interesting. I don't know if we needed to do all those steps. I thought most of them were needed, though, where we found all these pairs and sort of started here with where certain digits could go in row 5, and then that bounced around a little bit with the pairs we got on these German whisper lines. But then this step here, I think my favorite step of the puzzle is just that these all had to be the same high-low on the whisper line, but then these 2 cells both being high-low, one of them had to be something in the middle, a 4 and a 6 in this case, to break up this entropic restriction. So yeah, very cool. I hope you all enjoyed that and give it a try yourselves. Let me know how you did in the comments if you'd like to. But other than that, take care, and we'll see you next time.